Hello, I welcome you all to your own channel MSK Learnium. In this session, we will discuss one derivation which is related to the step function, and then at the end of the derivation we will see what is the step function and what is its significance in finite element problems. So let's start. The derivation of step function for one-dimensional linear line element means you have a one linear body. So first of all we will take one linear element and that body is kept in the xy plane. So first of all we will draw like this, that is, this is your plane, and in this xy plane one linear element is kept, right? So this is what you have, a linear element. The node, two node is there, this is node 1 and this is the node 2, right? So we have to see the nodal displacement for this node 1 is a q1 and the nodal displacement for this 2, that is q2, right? So the position of this node 1 and node 2 we have to locate. That let's say this node 1 is located at a distance of x1 from the y-axis and the node 2 is located at a distance of x2 from the y-axis, right? So as we are deriving the equation for derivation of step function for one-dimensional linear line element, it means that one linear polynomial equation you have to consider in terms of the x, right? So now we can say that here the linear equation is what? That this element is following the linear equation function, that is u is equal to a1 plus a2 into x, right? So this is the linear equation we consider for this element, that whatever the element we have taken right now we need to derive that relation for the step function. So here we go, that we can say assumed displacement field, assumed the displacement field. So what is the displacement field? That whatever the equation we have considered, u is equal to a1 plus a2 x, means u is the nodal displacement and x is the position. So this displacement is varying with respect to this position x, and this a1 and a2 are the arbitrary constant, right? So first of all what we need to do to get the nodal displacement, you have to find out the arbitrary constant a1 and a2 value. That a1 a2 value we have to substitute further into this equation and then we'll get the step function. So let's say this is the equation 1 and it is the linear polynomial. So here you can write for better understanding that it is a linear polynomial equation, right? Linear polynomial equation. If it is a quadratic, it will be in terms of a1 square plus b2 a2x plus c, something like that, right? So now we will take each node. That first we are taking at node 1, right? At node 1 what is the boundary condition? Let's see that at node 1 x is equal to x1 and u is equal to q1. At node 2 x is equal to x2 and u is equal to q2. That u is the nodal displacement, right? So here you can say at node 1 x is equal to x1 and u is equal to q1. When we substitute this boundary condition into this equation, that equation will become u is equal to what? You can write u is equal to, we can write q1 is equal to a1 as it is plus a2, x is equal to x1 will write, right? This is x1. So let's say this is the equation 2. Okay, now further we'll move to the at node 2. So node 2 is what? At node 2. At node 2 you can see again, that is when x is equal to x2, u is equal to q2. Is it or not? This is the node 2, right? So you have a at node 2 x is equal to x2 and u is equal to q2. All right. So what is that u? U is equal to a1 plus a2x. So u is become q2. A1 will be as it is plus a2 x2. This is the equation 3. All right. Now then we have to find out the a1 and a2. For that we can simplify this equation 2 and equation 3. So we can do that, subtract 2 from 3, right? So you can write that subtract equation 2 to that is we have written in Roman. So equation 2 minus equation 3, right? So when you equate that 2, this is the equation 2 and this is the equation 3. So it means what? That means q1 minus q2 is equal to a1 minus a1, that is a1 plus a2 x1 minus a1 plus a2 x2. So a1 will get cancelled, right? So on simplification, that equation will become q1 minus q2 is equal to a2 x1 minus a2 x2, right? a1 is get cancelled from both, right? So this is will become q1 minus q2 is equal to a2 will get common, that is x1 minus x2, right? So first arbitrary constant we got, that is a2 is equal to q1 minus q2 upon x1 minus x2. So one first arbitrary constant value you got, that is a2. Now this a2 we can substitute either in equation 2 or equation 3. We'll get the a2 value, right? So here we go. Just wait. So next we can say substitute a2 in equation 1, right? In equation 1, right? So equation 1 is what? That equation 1 is you have a sorry, not equation 1, in equation 2, right? Then this is the equation 2 is q1 is equal to a1 plus a2 x1, right? So a2 you already got, is it or not? That is, then q1 will become, q1 is equal to a1 plus a2 is equal to, we find q1 minus q2 by x2 minus x1, right? So this, see, this you can further simplify this, that is, you can also write that a2 is equal to q2 minus q1 by x2 minus x1, is it or not? So this value is like this, we can write, okay? So then a2 is equal to what? a2 is equal to, just now we modified that q2 minus q1 by x2 minus x1 into x1, right? So we can simplify this, we'll get the a1, that a1 is equal to q1 minus q2 minus q1 by x2 minus x1 into x1, all right? Okay, then further this a1 is equal to, let's simplify this, that is x2 minus x1. So this is q1 x2 minus q1 x1, and then when you open this bracket, that is minus q2 x1, and minus minus plus q1 x1, and this minus q1 x1 plus q1 x1 get cancelled. So let's cancel them, right? So remaining is what? q1 x2 minus q2 x1 by x2 minus x1. So this is your a1, right? That a1 is equal to q1 x2 minus q2 x1 upon x2 minus x1. So let's say that a1 also we got, right? So now we have a arbitrary constant a1 as well as a2. This a1, a2 we have to substitute in the equation 1, which we considered or assumed for the displacement field. So displacement field equation u is equal to a1 plus a2x, that equation 1, which is in terms of the linear polynomial. So in this equation we are going to substitute a1 and a2 value, will get the nodal displacement, right? So now you can say that substitute a1 and a2 in equation 1, all right? So here we'll go that substitute a1 and a2 in equation which? In equation 1, right? So u is equal to, you have a a1 plus a2x. a1 is what? a1 is q1 x2 minus q2 x1 upon x2 minus x1, and this is plus, right? So further u is equal to a1 plus a2x, q1 x2 minus q2 x1 by x2 minus x1, and a2 is equal to we got that is q1 minus q2 by x1 minus x2. Wait, so this is what you have, a plus a2 is q2 minus q1 by x2 minus x1 into x. This is a1 plus a2x. This is the equation you consider, right? So now you can simplify this, that when we simplify it will become like this, that is x2 minus x1, this is q1 x2 minus q2 x1, all right, and plus q2x minus q1x. okay, so this equation further, this is the u, so u is equal to that u is equal to, we have in this term you can write u is equal to q1x2 minus q2x1 plus q2x minus q1x by x2 minus x1. So here we can get common, that is if I take q1, so what is that, x2 minus x, and when we get q2, so it will become that is x minus x1. So when I'll take common q1, so it will become x2 minus x by x2 minus x1, right? And this plus, it is minus, and this is plus, right? So in this plus we'll get common, so q2 plus q2 we are getting common, so it will become x minus x1 by x2 minus x1, right? So this is the nodal displacement u we got, right? So u is equal to what, q1 this plus q2 this x2 minus x by x2 minus x1 and x minus x1 by x2 minus x1 is a safe function, right? So now you can write this equation, u is equal to n1 q1 plus n2 q2, all right? So this is the linear equation, one dimensional linear equation in terms of the safe functions, right, for bar element. Is it or not? Then here again you can write it in this mat format also, u is equal to n1 n2, right, and q1 q2, where q1 q2 are the nodal displacement, n1 n2 are the safe function, right? Now so again we will go here and then you can say that where n1 and n2 are safe function, right? n1 and n2 are safe function, right? So n1 is what now? n1 is equal to x2 minus x by x2 minus x1, all right? So this is the safe function we got, and n2 is equal to x minus x1 by x2 minus x1. This is the safe function at node 1 and node 2 we got, right? So now we can say what is the safe function actually, right? So safe function you have, that is safe function are this n1 and n2, we can say n1 and n2 are also known as what? Linear safe function. Why? Because it is for linear element, right? Linear safe function, right? Safe function, or you can say interpolar function or interpolar function. This is used, which is used to define the shape of the variation of displacement field, right, within element. means whenever the element is subjected to the load, there is a displacement will takes place. How the displacement will takes place, that idea will get from the shape function only, right? Or you can make one more note points, that is these are used to interpolate the displacement function, that is shape function. Like this you can make a point, shape functions are used to interpolate the displacement function. All right, displacement function. So then we can see how the shape function will interpolate the displacement function. So let's take node 1, right? At node 1, this is the work example, you can say at node 1, what is the position? That x is equal to x1, is it or not? Now shape function at node 1, n1 is equal to what? x2 minus x by x2 minus x1. So now in this equation, when you substitute x is equal to x1, that equation will become like this, x2 minus x1 by x2 minus x1. These two are cancelled, it become 1. Means at node 1, values of shape function is what? 1. Again at node 1 only, we'll see the shape function about 2, right? That is n2. n2 is equal to what? X minus x1 by x2 minus x1. So it is what? X is equal to x1, you can substitute x1 minus x1 by x2 minus x1. So this is x1 minus x1 is 0, so it will be 0. Means what? That at node 2, is it or not? At node 2 we don't have any shape function, means there is no displacement at node 2 for x is equal to x1. So this is the significance. So the shape, how the element will get the shape for this condition, we can draw here. That is, this is the element, right? And like this is the node 1 and this is the node 2. This is the length, that is what you can say LE, is it or not, right? So you can shade them. Similarly, we'll go for the node 2. At node 2, we kept x is equal to x2. So when x is equal to x2 means n1 is equal to x2 minus x2 by x2 minus x1 is equal to 0, right? For shape function at node 1. And n2 is equal to what? That is x minus x1 by x2 minus x1. So x is the x2 minus x1 by x2 minus x1 is equal to 1. Means at node 2 that you have a shape function value is 1 and that at point 1 it is 0. So the interpolation we have like this. This is 0 and this is the 1. So it is 1. This is the node 2, right? And this is 1. So here the shape function is 0 you got, n is equal to 0 and n is equal to 1. So when you combine this for the combined element, that the interpolation will be like this. That is for node 1 it is like this, at here it is 0, and again for this condition it is 1 and here it is 0. Is it or not? So this is the shape function n1 and this is the n2. So this is what the significance of a shape function in your finite element problem for linear element. Thank you.